All right, welcome everybody. In this video, I want to wrap up our discussion of working with the Bootstrap distribution for the mean mandible length of golden jackals. So we've talked about Bootstrap distributions in general. We've talked about the golden jackal data specifically, and then we constructed a Bootstrap distribution in the previous video that's pictured up above over here. So all of these values that are plotted in this bootstrap distribution, they were created with this for loop that we set up earlier and where we picked a bootstrap resample, calculated the mean of that resample, and then we stored all of those statistics to a vector called boot underscore dist. And so when I'm looking at this histogram, I'm looking at the distribution of all of the values stored in that vector boot dist. And those values correspond to means from different bootstrap resamples that we constructed. So a 95% bootstrap confidence interval, we need to find these two cutoffs. One of them at the 0.025 quantile, one of them at the 0.975 quantile, and then in between those two endpoints, we've excluded the upper 2.5, we've excluded the lower 2.5, so we've excluded 5% of the bootstrap statistics. So that means we've got the middle 95% included in our bootstrap confidence interval. So really, once I've got my bootstrap distribution, it's just calculate the quantiles, the two quantiles that I need for my two endpoints. And those quantiles are going to depend on the confidence level that we choose for our confidence interval. So we chose a 95% confidence interval. So I will call the lower one lower cut. And these values are all stored in boot dist. So what I want to do is go into the vector boot dist and pull off the quantile corresponding to 0.025. That's going to be my lower estimate. The lower cutoff for my confidence interval, and then the upper cutoff, we would use the 0.975 quantile. So I'll calculate them. I guess I could print this all out in one shot, but I'll take a look at what those values are down here. So my lower cutoff is 109.4 millimeters. My upper cutoff is 112.7 millimeters. So what this question is asking me to do, I've got my cutoffs for the confidence interval. Let me add these to the picture that we had before so we can just make sure that these cutoffs seem reasonable. And then ultimately we want to interpret these values. How can we interpret these values in this context? So we had this picture before where we've got this bootstrap distribution, and this vertical line in red is the original sample mean of the sample that we collected of 20 mandible jaws. So all I did is I took this code, I copied it, and pasted it down here. So if I run this code cell, I get exactly the same plot as above. I want to add two blue vertical lines to this plot at each of these cutoffs. So I don't need to change the data. I don't need to change the histogram. I want to add some additional vertical lines. So I'm going to add one of them in red at the mean of our observed sample. I want to add another line at lower cut and another line at upper cut. So this is going to draw three vertical lines, 1, 2, 3. They're all going to be dashed. So I'll just keep that as one argument to define all of the lines. But I want the lines to be different colored. So one thing I want to make sure is I include a comma over here. Each of these arguments should end with a comma. So the line type is going to be dashed for all of them. the color is going to be different. I want the line in the middle to be blue, but I want my two cutoffs for the confidence interval. The line in the middle is red, and I want my cutoff for the confidence intervals to be blue. And I want to end that with a comma, and they're all going to have a line width of 1. So all I did here is I added 2 additional vertical lines that I decided to color blue. Otherwise, I'm not changing anything else. The histogram is the same, the labels are the same, and I'll use the same layout. So if I run this code, I should just see everything should look the same, but I've got 2 blue vertical lines added. Perfect. And so we can see that it seems reasonable that in between these 2 lines sits about 95% of the Bootstrap distribution. Out here is the upper 2.5%, and to the left of the lower blue line is the lower 2.5%. So finally, if we want to interpret the practical meaning of this interval that is going from 109.4 to 112.7, informally, we can say that this interval from 109.4 to 112.7 millimeters gives us a range of plausible values for the mean mandible length of all golden jackals. That's a good interpretation. It doesn't mention anything about the 95% confidence level. So if we want to kind of summarize and include that information in our interpretation, a more formal interpretation of this interval would be that this is the odds of success. So there's a 95% chance that this interval from 109.4 to 112.7 millimeters contains the true population mean, which in this case is the mean mandible length of all golden jackals. Okay, thanks everyone.